we're going live. Okay, we should be live. I'll wait to see if there's anything in chat to to let us know. And we are live. Thanks, Akash. Hey guys. So I have here with me Rev, and Rev, if you'll introduce yourself for us.
Hello, everyone. My name is Rev Libridian. I am the Vice President of Simulation Technology and Omniverse here at NVIDIA. Really thrilled to be here with Harrison to walk through all of the cool stuff we're announcing at GTC.
Yeah, cool. So if you want to tell us about some of the kind of new things that we're expecting to see about Omniverse and all that.
Wow, yeah, there's a whole lot of stuff that's going to be revealed here in the keynote. For those of you that haven't seen it already, essentially the whole keynote was created with Omniverse, and pretty much every demo that we show for anything else has an Omniverse component to it. Omniverse is our virtual world creation and simulation platform. And first and foremost, we built it for ourselves, so that we could do our work in all of the areas that are important to us at NVIDIA, from robotics to computer vision to autonomous vehicles to virtual production of the keynote itself. So the big announcements for Omniverse directly are there were 4 of them that were specifically about Omniverse. First is there's a new app that we're going to be releasing soon called Omniverse Showroom. It's a easy to use app where you can get a whole bunch of little cool demos to kind of see the power of Omniverse and all of NVIDIA's technologies. We're going to start off with a few demolets inside it, but over time there's going to be a huge number of them that will just keep adding. Every time we do something cool, new physics technology, new AI technology, we'll be adding one to Showroom. The next one is Omniverse Farm. This is a system that we built that is very powerful. And general. It allows you to take virtually any batch kind of process, including rendering within Omniverse, to do synthetic data generation or render frames for your videos, but also just about anything else. Like you could do file format conversion or physics simulation, whatever you want to run in batch on one machine or more. You can easily set up Omniverse Farm to manage all of your resources and distribute that work. We used it to create this keynote, and actually the previous one as well. We had at some points 1,200 GPUs all running simultaneously across our workstations to various clusters we have around NVIDIA and different data centers to the cloud. We use the public cloud as well. So all of the stuff you see rendered in there.
Is that what you're using for the car manufacturing? Like we seem to see that a lot. Is that something similar? Is that what you're using for that?
Yeah, for the beautiful videos that you see rendered for like the BMW factory of the future.
Yeah.
There's multiple rendering modes in Omniverse. We have the real-time mode, but we also have an offline rendering mode, path tracing, as well as the iRay renderer, which is an extremely physically accurate, really true simulation of the physics of light. And so you have a spectrum of quality and accuracy versus speed.
Right.
For the keynote, we want everything to be as beautiful as possible, so we can flip a switch and go take all of the stuff that's real time and give the computers a little bit more time to render the images in a more beautiful, accurate way, and something more similar to what's done in film, for visual effects and CG movies, where they often can spend many hours or even days worth of computer time to render a single image. You have the option to do that, with Omniverse Farm, we now give the capability of doing this kind of large-scale rendering to anyone by allowing you to harness all the resources available to you, whether that's your workstation, maybe your notebook, to instances in the cloud that you're renting. You can combine them all together and make it one big resource pool and distribute that work to it easily, and it's nicely integrated with our Omniverse apps. So with just the click of a button, you can submit thousands of frames to get rendered wherever you have resources. It's really powerful stuff, and I think it's the beginning of this journey that we're going to take everybody along to unlock the capabilities of all the computing resources that are available these days through the cloud and even just in front of you, that we're not harnessing to its fullest, because it's just so hard to manage setting up all of that work. The other two things that we're announcing, first is AR. So we're making available the apps necessary to connect to an Omniverse server. So the rendering can happen on the Omniverse server side, but displayed remotely on a tablet or your phone.
And when you say like Omniverse server, do you mean like someone can have that running locally as well, not just
yes, absolutely, yes. Yeah. This is not cloud versus not. It could be either, but you could run on your laptop or your workstation that's RTX capable. Run Create or an Omniverse kit based app, and stream that rendering over to your iOS device using our Omniverse remote app, and the device knows its position and pose in the world through SLAM and the tracking that it's doing to localize itself in the world. That's fed back to the Omniverse rendering server, which then affects the virtual camera. So in effect, what it does is it allows you to have an AR experience where the rendering quality and the content, the scale of the content you can do is at the scale of the computer you have available to you, the workstation or whatever you have in the cloud, instead of the device that you're displaying it on.
And to cut in for a second, so we're watching like the intro to the keynote now. This is all rendered with like Omniverse, correct?
Oh, absolutely. And this is actually Jensen's kitchen in his home. I've been there a few times, and it looks exactly like that. It's kind of freaky. That's crazy.
That looks so real.
How close it is.
First time I watched, like the last one though, he was in his kitchen.
Welcome to GTC.
I could not have told you he was in a kitchen, or he was in like a fake kitchen,
a virtual kitchen. Yeah. We're at the point now where we
have a jam-packed keynote.
Reproduce reality pretty faithfully. Now, kudos to our creative team, which is world class. The artists we have on our creative team are some of the best in the world that come from visual effects and the CG world, and so they built his kitchen and applied all of those materials and matched it exactly, using their craft. Our goal at NVIDIA, and particularly with Omniverse, is to democratize that ability. We want to, over time, make it easier for the layman who's not an expert to be able to construct scenes like that at that quality, fidelity, and reproduce the real world faithfully like that. And with the advent of AI and deep learning, we believe that there's a path there, and it's not that far off. We're going to be able to take average people and give them tools that are AI amplified by AI to turn them into expert artists and craftsmen, 3D craftsmen.
I just saw a question in the chat. How long did it take? I was wondering the same thing. So like that kitchen looked so good. So like how long did it take to design that, and then also how long did it take to actually like render that video? Because surely that's like what you were talking about, like the highest end possible.
You know, I don't have the exact numbers in front of me, but I believe that they worked on modeling and texturing the scene over the course of many months, but also not in the front burner. That we decided we were going to do that a year ago at GTC fall last year. We had done an actual kitchen keynote where it was in his kitchen, and they used that opportunity to go take thousands of pictures of the kitchen, so that we could rebuild it with photogrammetry. But we knew that the quality of what you're going to get from photogrammetry would not be what we needed. That was just done for reference. So from there we spent months.
I'm still trying to get a grip on reality then. So the first GTC that I saw with him in his kitchen was when he like pulled out the A100s from the oven.
Right.
Is that real or fake?
That was GTC spring of 2020. And it was like March or April or whatever that was, right when COVID had started.
So is that real or fake?
That was real.
Oh, okay. But there were scenes from there that like kind of like he did here, where it kind of explodes into a clearly a CGI type scene. So was it?
I don't think there was in that one. We did that later.
Yeah, you guys are messing with my brain, I guess.
Yeah, that keynote. I mean, we weren't planning for that. That year, we had plans for some other amazing stuff we wanted to do, and we were going to do live, like we always used to do before.
Yeah.
And there's all this cool stuff that we were going to show off in Omniverse on the live stage, with some magic interaction with the scene. But we had to scrap all of that because everybody had to go home for quarantine. So we just cooked up the kitchen keynote idea out of necessity there. But as we were doing that, we realized, hey, why don't we turn the kitchen turned out to be a pretty iconic thing, kind of like his leather jacket. Everybody was enthralled with it, and his spatulas and all that. So we had the idea to reconstruct in the virtual world, and now we have that kitchen preserved forever. So even when he remodels his house, we can keep that and use it for our purposes forevermore.
Oh, I muted him. I'm sorry. Oh, I thought I'd paused it. There we go. So like the background here, is that real or fake?
It is not unusual for us.
I believe that's rendered.
Yeah.
I'm not sure. Sometimes they do. Sometimes it's real. Sometimes it's not. This was done using these modern virtual production techniques, where we have a LED wall system and a robotic arm that driving the camera.
Right. But is that?
It's kind of like how the Mandalorian was done.
So is he? Yeah. So like when you guys do those scenes, is Jensen just on a green screen or what?
No, he's not on a green screen. That's it behind him on the LED walls, projected. So it's in camera compositing.
Oh, man.
Like the Mandalorian.
Yeah.
Maybe I might not. Maybe I shouldn't be giving it away. I think our creative team probably wants to talk about some of the magic later. But yeah. We do all kinds of stuff. So our team is super pro, and they're pushing everything to the limits. We love using them as our guinea pigs for Omniverse because as we develop all these cutting edge technologies and push the limits of real-time rendering and physics, somebody has to use it the first time and tell us what works well and what doesn't work well and what's buggy and all that. And so we force it on our own teams first. And they kind of find the limits of it, go through all the pain, curse at us, and then we make it better, so that by the time we give it to others, it's already proven.
Well, definitely like one thing I really enjoyed, like at least on the outside looking into Omniverse, like I'd heard the name. And how old is Omniverse? Like, or really, when was the first time you guys mentioned Omniverse?
The first time we mentioned it publicly was GTC Spring 2019. That was the first demo we put up there, where we showed a collaborative demo along with our nascent renderer and kit. We showed 3 applications connecting simultaneously. It was Unreal Engine 4, Substance Painter, and Maya, and you had 3 different people live editing the world simultaneously. Something we hadn't seen before, and they were doing this magic there. But the vision for Omniverse was much greater than what we showed there, and we knew that. But it's just too hard to tell everything about the vision all at once. You kind of have to do it in stages and actually show that it works. It wasn't all done yet either. It's still not done. This is going to be a continuous thing that we contribute to. But we knew that we needed to build something like Omniverse a long time ago.
Let me just pause for a sec. So what's on the screen right now, I believe this is all Omniverse. Is that right?
Yes, it is. And that's the real-time mode, I believe. So that's showing, it's a visualization of the route planning done by our new ReOpt system that's using the accelerated route planning system to make logistics and all that far more efficient. So the route plans are fed into the Omniverse here to drive these robots, so we can visualize them doing their work.
Yeah, that's so cool. One of the things that I found really cool about Omniverse, like when I first started using it, because all I was really trying to do is get a simulator for a robot. That's it. And so I was looking at all these other simulators, but with Omniverse, like one of the things that's so easy is like you have like that URDF file that describes the robot, but then when you save that, like when I spend all this time like creating the scene, I'm doing that all like manually. It's all a bunch of like drag and drop kind of stuff, and like you just bring in like a ground plane or some other asset and stuff like that, and then you just save that as that like USD file. And at least like I'm sure that kind of concept with like maybe with like Blender or something like that is super common, but I don't know anything about Blender. And at least in Omniverse, like when I'm trying to create a scene for my robot to navigate in or whatever, it's just so simple, as opposed to with any of these other robot simulators, you have to like code it, and it's like coding like a UI. It's so painful to like code something that is visual like that, at least for me, and I think it's true for a lot of people. Whereas here, like if I want to have 2 or 3 robots, like I just copy and paste the robot. Like it's really simple, and I drag it exactly where I want it to be. And if I want like a ramp, I just add in a ramp visually, and then I can save that. And then the same thing is that like other people can do that, and they can just share that with me. Like they can share their USD file with me. And then if I want to make some little tweak or edit or whatever, like it's really easy. I mean, it's way easier than any other robot sim out there. And obviously that's not the only, it's not just for simulating robots. It's more than that, but it's like even just for that, it's got to be the best, if not one of the best simulators. And I feel like people don't like, that's not the first name that comes to people's mind when they think of robot sims. So that's why like I'm super excited about Omniverse and just Isaac Sim inside of Omniverse for that reason. Like it's so easy. And then on top of that, yeah, it's definitely the best looking sim too, especially with like.
I'm so glad to hear you say that. And our Isaac Sim team and the Omniverse team will really appreciate hearing that, because they've been working on this for a long time. And what you said right there about what the benefits of using it, with making it easy to construct these worlds, to bring in this data together and combine the robotic stuff with other 3D data. That's precisely why we built it, because we had those same problems internally. There's a lot of really great tools out there for constructing 3D worlds. Tools like Blender and the Autodesk tools like Maya and Max and Houdini and whatnot. But the number of people on this earth who really are masters at using the 3D software is pretty small. It's essentially, people that do visual effects and that sort of stuff or make games. And there's a large number of people that are doing that, but not in the grand scheme of things. If you're doing anything else, if you're doing robotics, you're doing simulations of your factories, you probably don't have one of those experts or any number of those experts, like a team of them on your team, to go build virtual worlds for you. And we saw this internally at NVIDIA because we have some of those experts, but we also have a whole bunch of engineers who need to do simulations of 3D worlds for building robots, autonomous vehicles, and various other things that we do. So first and foremost, we said, how do we make it possible so that we can leverage all of the existing tools, all of the content that's out there, to assemble together 3D worlds that could then be used for simulation. And this is what we designed. We said, first we need to create Omniverse and make this connection and have these standards to make it easy to bring data in and out of all the other tools, have a common language, just like we do for the web. We take HTML and all of the web standards for granted, but they're the key to why we can do any of the stuff we're doing right now. We need the equivalent of that for 3D worlds, so we started from there. But that's only the beginning of the journey. Once you have that foundation, you can then link in virtually any 3D tool that's out there, any 3D simulator, and you get this awesome network effect. Every new thing that's added into the system, everybody benefits from it. So you benefit from the fact that some tool that you will never use directly is connected because somebody else out there can now feed you data and information that you could leverage.
Yeah, do you guys have any plan to, or maybe there is something and I've just missed it, but like one of the things, like when I got Isaac Sim, was there was just like one big asset package that you could grab. So there was like a warehouse in there and stuff like that. Is there any plan, or is there something I've missed where you can get like people can share, like for example, there's like cities and stuff that people are building and it's like, wow, I really want that. I want to just download and use that. Is there a way for people to share those?
So yeah, first off, like we want to make more of those things. So our plan is to increase the number of assets that just come with Omniverse. And you can see over the course of the past year, we've been steadily increasing that. And I think that's going to accelerate even faster. So out of the box, you're going to get a bunch, but you can never have enough either. One of the great things about Omniverse is all the connectors we have to all the different 3D tools and other systems, which makes it really, really easy for you to import content that exists in other libraries. So there are a bunch of 3D content libraries out there you can just go buy, or some of them provide free assets as well, like Shutterstock's TurboSquid. They've been around. TurboSquid's been around now for a few decades. So there's a large library of 3D content that's been built up over the years, million or so 3D models there. You can go to Sketchfab, which is a newer one. Epic acquired them recently. They have a bunch of great content, and all of it is available as USD. So you could just download either their free.
What was the name of the Shutterstock one? I'm just
TurboSquid.
TurboSquid. Interesting. And is that just like a
CG?
Is that like a single asset, or would there be like environments?
No, it's a whole library. It's where artists build up scenes, and they sell them on the marketplace. So there's this marketplace of there's many marketplaces of these assets that other artists can sell on. So the problem has always been that there hasn't been a common language, a common format to describe these assets. So as a roboticist, you want URDFs, but the artist might be using Blender or Maya to create their assets, and what they upload as it probably isn't compatible exactly with what you need. So there's usually a whole bunch of work you have to do to ingest those assets, convert them, and then you lose information like materials and stuff typically in that process. But with the standardization on USD happening, that's it's becoming a non-issue. And that's what we're trying to help with. So given all the connectors that we have, you can take advantage of those. There's also the stores that are available with the game engines. With Unreal, there's the Unreal Marketplace. There's also the Unity Marketplace. So you can go buy assets from the Unreal Marketplace and use the Unreal Engine connector to convert to USD and connect it to the Omniverse Nucleus server and bring it right into Isaac Sim that way as well. So there's many paths. Our whole intention here is to make it so that everything becomes USD, this common standard, and we'll provide as many tools as necessary to bring from different forms and different tools into that common form. Once it's there, you can use it for anything. It's very easy to move around. And increasingly, USD is becoming the standard for many of these marketplaces as well. So you won't even have to convert in many cases. And in the future, I think that's going to become a non-issue.
Well, at least for like converting from URDF to USD, I found that to be very simple. As long as, there's obviously like...
Yeah, we did a lot of work there. I mean, all that conversion stuff, it's not rocket science, but it's a lot of work.
Yeah.
You have to like look at every corner case and just convert tons and tons of different content. And a lot of the times the content you get, they actually violate the standard. There are things, the standards maybe aren't that well defined or whatever. So you have to deal with malformed content and all of that. And so we have this amazing team within Omniverse, within the Omniverse group that's just so dedicated and passionate about making that work well and making it work right. And they've been spending years. Every time we see some asset that didn't convert over right, they go figure out why, and they add a little bit more code, a new path to our converters. And the end effect is it just works for you. And when it doesn't just work, you let us know, and we'll be on it, and we'll make sure it works, because that's key to making all of this happen. If we can't exchange information freely without friction with each other, there's no way we're going to build the large virtual worlds we need to do the simulations that we need for all the stuff we're talking about.
Someone in chat had noted that maybe that converter is only working on Windows. I lost the question. I saw it. Is there any like ETA?
It depends which one.
He just. I'm not sure which one it was because he just said a converter that he's talking about, and I couldn't remember. I couldn't remember which one specifically that was. The UE4 connector, he says.
Yeah, maybe. I'm not sure. We let different connectors work on different operating systems. Basically, we can't go build connectors for every application on every platform. There's just too many tools out there to connect to, and so we as big as NVIDIA is, we still have limited resources. So we have to prioritize which ones we do first, and that's based on what the demand is. So if there's a large amount of demand for a particular tool and platform, then we'll pop that up. But for the Unreal Engine connector, we actually provide source for it along with the connector. So you can go build it, and if you really need it to run on a non-Windows platform, you're welcome to do that yourself. If there's a lot of demand for that on Linux, which I don't think we've received much, then we'll consider supporting that as well. It just adds more burden to our QA and CI/CD and all of that stuff.
Yeah, I would imagine Windows would be the first one you would want to support anyways. The other question I have is like with Isaac Sim, that is, unless I'm mistaken, only Linux? Is there a plan or ETA for getting that on Windows, or maybe I'm mistaken already? But I think
It's the same thing. Yes, our hope and our plans are that everything we develop is on every operating system. And Linux is very, very important to us because that is the operating system of the cloud. And we imagine over time, most of the cycles that are run in the Omniverse are actually in the cloud. So most people are going to be experiencing Omniverse and our software running somewhere remotely anyway. And so Linux is kind of the default for that. But for the robotics community, what we found is that primarily they are Linux and Unix in general, Unix based. Some run on Windows, but at least on the professional side or in academia, on the forefront of robotics, that was a requirement. Internally, we have a lot of robotics we're doing. We have amazing roboticists. We have a world-class research lab, a robotics one in Seattle, led by Dieter Fox from University of Washington. He's super famous, that community. He wrote the textbook on robotics. And all of them demanded Linux because that's what they run their robots on.
Yeah.
So that's what we prioritize first, but we do hope that sometime soon we'll be able to put a Windows version out there. Omniverse itself is agnostic to this.
Yeah.
It's we from the start designed it so that it could be multi-platform and Linux as a first-class citizen, which is not often the case for real-time rendering. Engines typically bias towards Windows or consoles, not Linux, because I
was pretty surprised that it was on Linux, to be honest. So,
yeah. But we knew that we need to have Linux for the professionals that are in the spaces that we care about, like robotics, and also because we need to run in the cloud. And so that's a lot of extra work we did to get it to run there with Vulkan. Not only are we running on Linux, but we're pushing the limits and the bleeding edge of ray tracing with our drivers and our hardware in Linux, and that nobody else is pushing our stuff like we are in this case.
Yeah, I want to pause for a second and go back to. I assume this was Omniverse as well. The avatar, the Jensen avatar. So I've only seen it. I haven't actually used it. So obviously this is using his voice as well, which is previously referred to as Jarvis, now called Riva, I'm assuming. And then also the avatar.
That's right.
Is that audio to face, or what are you using for that?
Yeah. So this is a short piece in the or I think it was like 30 seconds or a minute. They showed it here, but this is really I think out of the whole keynote, this is going to end up being the thing that really stands out, and this is
just a little bit
special
of
moment in history with what we created here.
Background for me is like, this has been like a dream of mine, is to basically have, and a little bit later there's a more realistic. So you got like the avatar, which is fun, but then there's also another. I think it's audio to face, but it's a more realistic face. And my goal would be to have text to speech of my voice. And I've been like slowly over time just like reading audiobooks into my microphone and captioning those. And I've actually been captioning those with, back then Jarvis, now Riva. So I've been using that to create the captions and then train the text-to-speech model with my voice. And then you've got your voice, you've got the audio to face. And then it's like, you've got this whole thing. And then now it's like, I don't even have to, it's like you said, Jensen's Kitchen is forever saved. It's the same thing for me. Is
exactly.
I could just be forever, just live on forever making videos on YouTube. Maybe use GPT-3 or something to continue making the videos.
That's exactly right. Yeah. We're if you had told me 10 years ago that we were going to be, that 10 years from that day we're going to have what we showed here with Toy Jensen.
Yeah.
I would have said you're crazy. That's never going to happen in my lifetime. And I've been continually having to reevaluate what's possible since this whole deep learning thing started. It's been crazy, but what we have here is a set of many amazing innovations and inventions. It's not just one thing. So it's starting with Riva. Riva has actually many components to it. It's all things related to speech and language. It has ASR, so you speak to it and it understands you well, regardless of what your accent is, and it's extremely robust,
And fast.
world
I think
class,
that's the
fast
thing
and
that was
robust.
surprising to me was just it's like it's instant. I mean it's not instant, but it's like
And it has to be because we need the end-to-end latency from when you
yeah.
speak till till it gives you the answer back to be like what you would expect in a normal conversation, which is like a second or less.
It's
Uh,
definitely less. I mean, it's so fast, and that was just on my GPUs here at home, and so yeah, that was I think for me what's
so
been so impressive is how quick these models are able to just do inference.
performance matters
Hmm.
in real-time interactive applications. Performance is very, very important, and that's what NVIDIA is about. It's about accelerating computing. It's what we do. So we go torture ourselves to shave off microseconds off of latency. That's our mission, our driving force is to do that. So, and in this case, it's extremely important. But we take the ASR, we take your audio, we convert it into a form, into a text form that is then fed into our natural language understanding models. Um, we just trained this huge model. I think it's like 500 something billion parameters, the Megatron model. We'd made an announcement a few weeks back of this model that we had trained. It's 4 times bigger than GPT-3, the OpenAI model. It was trained on essentially all information we had accessible to us from the internet, like Wikipedia and stuff like that. Um, uh, and and basically it learned all of that knowledge. So it takes that and it formulates an answer based on what it's learned. We then convert the answer into audio with the text to speech generation we have that was trained on Jensen's voice. So it sounds like Jensen is answering for this AI, and that is then fed into audio to face to generate the facial animation. And based on the state of the answers and stuff, we also trigger other animations. All of that is driven inside of Omniverse in real time. That whole scene is rendered in real time and interactive. So we not only have a voice for representing the AI, but now the AI is embodied. We have Toy Jensen, who can communicate with us not just through voice, but hand gestures and expressions. When it's thinking, it's doing the inference
Yeah,
on the question you asked. You'll notice it kind of looks
yeah.
away, and so we're right at the beginnings of creating an embodiment for our AIs that can communicate with us through all the channels that we take for granted as humans. We know now, after being in lockdown and quarantine for almost 2 years, how important it is to be in person with others and get all of that bandwidth of information, much more than just the voice communication. And so we're providing these AIs a mechanism to do that in these virtual worlds. And eventually we'll extend that to our robots, so we can have them teleport out of the virtual world into our real world.
So with the Jensen toy, how much audio of Jensen's voice was used there? And then did you use was it the transfer learning toolkit is that what you guys used to do it, or?
I believe so. Within Riva, we have some mechanisms. I can't tell you the exact numbers and stuff, but there's some way with very small amounts of training we can do that quality of text to speech, and it's getting better and better all the time. I know for a fact that it's not a lot of data because Jensen's time is precious. So we couldn't put him in an audio recording booth for days at a time.
Yeah, I think the last time I looked at the speech to text, I forget, you know, there was the default voice, and then I don't think that the transfer learning toolkit even had like the option to do any sort of transfer learning on that into a custom voice. And as far as I know, kind of there's really no good industry standard way to do transfer learning on a voice that sounds pretty good.
Yeah, so that's part of Riva, and what you're going to see. There's a bunch of announcements coming out around here, so you can dig into the details as they come out. But whatever we're announcing now isn't the end. We have a lot of other stuff we're cooking up in house, and all of that will be made available as soon as it's ready. So Riva, with Riva, we're just at the beginnings of this, and we're moving very fast. So you can expect all of the stuff that you want. It's not going to be long till you can get access to it, even if it's not available immediately today.
Yeah. I mean, I've said it a million times that I think it's just so crazy. Like even when I was going through the Jarvis now Riva stuff, it's just like, and you were even saying like how many systems are involved in doing just the Toy Jensen thing, right? There's so many. Just like neural networks, there's like 3 of them, and then you have all this like rendering stuff.
Oh no, there's many more than 3. There's many more. I gave a very simplified view of what happened there.
Right. Well, that's what I mean. Is like you've got something that's coming in for the ASR stuff. You've got something that's got to generate the audio, and then even for the ASR, I don't even know how many are involved just with ASR because you've got. Obviously, something's got to process that audio. Something has to like transcribe that audio, and then even in the video that I did with it, you can even see that sometimes as you're speaking, it has the caption or the transcription, and then it changes as you continue talking, and it kind of figures out what are you actually saying now. And so there's just so much going on, and just thinking about how much time it would take for somebody like me who's got a decent understanding of like I could do all this myself, but it's just so fast to grab these things and just
it's come to the point actually where individuals like us we couldn't train any of these networks ourselves. We've built internally we have a supercomputer called Selene. If you look at the top 500 supercomputers in the world, there's a top 500 list. It's number 5. It's the largest enterprise industrial supercomputer in the world. The ones that are bigger than us are all national labs. They're like owned by the governments. We built this supercomputer for our researchers, for our engineers to go create these models. Mm-hmm. That Megatron 500 billion parameter model we created, that took months to train on this supercomputer. The supercomputer costs, I don't know, hundreds of millions of dollars. No individual could justify buying one of those. Well, even just one run on it is many millions of dollars.
Even on the DGX station, that A100 machine that I had for a little bit, I trained a transformer model for, I call it like GPyT, so Generative Python Transformer. That was a 125 million with an M parameter model. I mean, it's just a baby model, and it took a decent amount of time to train on that size machine. So when we're talking about these models that are 500 billion with a B, it's like it's just what's required to even train those kinds of models and have them be like with like the ASR models and stuff that you.
It's not available to average people or average companies. Even if you have the money to do it, the expertise to build that supercomputer and to operate it and to design the algorithms to go do the training on that and have it scale and optimize for it, that's a rare skill, and it's one that we've been we've been cultivating for the whole time we've been here at NVIDIA. This is exactly what we do. And also, it's not like you train it and you're done. That's it.
Yeah.
The software is done. The moment it's done, it's already outdated.
Yeah.
There's new information in the world, and the AI has advanced. So you got to start training the next one. So it's just kind of this endless thing.
Yeah.
So individuals and small companies really can't do all of this, and our mission is to make it so that individuals and small companies and startups and everyone can have access to all this technology. We'll do it for them. The other big tech companies can go build it for themselves, but somebody has to make it for everybody else to use. So if you want this amazing stuff, we'll go do the hard work for you, and we're happy for you to take it and use it to build your own amazing applications. You can go focus on your specific value add. What's the special sauce you're bringing to the table? You don't have to worry about building the basics.
Yeah. I mean, I totally agree. I mean, the models that everyone hears about these days, including like things like GPT-3 and all that, you just could never train those models yourself. And then a lot of times these models are closed, so you can't download that model. You can't do any research on that model. We don't really tend to know like how those models even work, or like what are their downsides. We can't even do research into that. Whereas like most people could do research, possibly not into GPT-3. Probably most people couldn't even inference GPT-3, or they could, but it would take a really long time. but yeah, it's just it's cool to see a company that puts all these things up. Like I remember the first time I found let's see, what is it? I'm blanking on the name. The NVIDIA GPU Cloud, NGC. That's where you go and you can just download these models, and like you have them in like Docker, and then also just like the weight files and stuff like that. You can just download them and use them. And I just think that's so cool because, like you said, I think a lot of these models people don't respect that. It's not like you sat down and you just knew like the exact hyperparameters for that model and trained it one time.
Not at all.
No, yeah, you had to make many attempts.
You had to go to many iterations, and it's very expensive to do that.
I mean, probably, first of all, the machines are in the millions, but then also just the amount of time, money, energy, human energy, and also just electricity that goes into making those models. I mean, these are very, very like expensive to train models. So it is really cool. Like we all want like open models and stuff like that. But, in the case of things like GPT-3 and stuff, or even like Megatron, as you mentioned, I think people don't realize like how tough those are to make, both in like human capital and then just real like money capital. Like it's just tough.
Right. I think you're right. I think people don't really understand and respect what's involved with that. One way to look at it is that modern AI, deep learning, is essentially a completely new form of software development. In the past, software development was you could have a software engineer with a laptop and a text editor, do a bunch of typing, and then they run a compiler and it executes for some period of time. We complain it's always too long, but really it's a short period of time, minutes, maybe tens of minutes at most. And then you produce an executable that you could then upload to your friends or your customers or whatnot, and they run it, and there you go. And that's expensive to do, but really limited in terms of the amount of compute you need to create it. The investment in compute. You can do it on virtually any laptop. What AI and deep learning is essentially a new kind of software development where algorithms that we have not been able to design ourselves as humans, we outsource to software to write. So we create software that writes software. Because for the kinds of things we can't do. So the image classification was the classic one that started all of this. We couldn't write an algorithm that could detect the difference, to detect that an image was a dog or a cat accurately. So we developed this new kind of software development where instead of us directly coding what that is, we feed this software a whole bunch of data, and it produces some software for us, a neural network that could then do that. So in this new form of software development, a fundamental prerequisite, a tool, is to have large amounts of compute to do that transformation from data into the algorithm. That you no longer can just do this on your laptop. You need a big computer to do interesting things, anything that's innovative, pushing the limits. And we know that we're nowhere near full artificial general intelligence. So by definition, we're always going to be pushing the limits on as big a computer as possible to be right there on the cutting edge. And so the game has changed now in software development. We recognized this really early on, and that's why Jensen immediately started investing in building computers, supercomputers, for our own engineers and researchers. We have Selene because we knew that is a prerequisite. You're not even in the game if you don't have a supercomputer to train these models. But our hope is to take all of the good work that we're doing here and all these investments and share it with everyone so they can build on top of it. We're not going to hoard it for ourselves.
What would you say like the top like objective, like what was the idea behind creating Omniverse? Because I mean there obviously was 3D environment creation stuff. What's the plan? Like what's the long-term plan with Omniverse, especially when like right now it seems to me there's like so many like side apps. Like you have, it's called Create, right? And then you have got like Isaac Sim, for example. And like I feel like I can do a lot of the same things in Create as I can do in Isaac Sim. So like, is there a plan to ever kind of like bring everything together? And then also, what was the main idea behind Omniverse?
So there's two parts to Omniverse, like two sides of the same coin. The first part is about building virtual worlds. Before you can do anything with the virtual worlds, you have to be able to construct them. So we need virtual worlds that are large, that are representative of the fidelity that we find in the real world, that match parameters in the world, so that when we run our simulations on them, we can be certain that our simulations are producing accurate results. We need the materials and how they look, how they behave in our physics systems to be correct. And building these worlds are hard. If you look at any industries, any areas where people build large virtual worlds, typically it involves many different disciplines, teams with many disciplines working together using a variety of tools, not one tool, but many different tools that are specific to their discipline. So you could go to Pixar and see what their pipelines look like to make Toy Story 4. And in that pipeline, there'll be 1,000+ artists and engineers all working together to construct the virtual world they're going to render. They are using many external tools like Maya and Houdini and tools for painting in Photoshop, you name it. Virtually everything is used. But they also have a ton of tools they've written in-house that are specific for how they do their development and their movies. They have their own animation system like Presto. And so the problem that we've had throughout the history of computer graphics with all of these tools is none of them can work together. When you export and import into from one tool into another, generally that process is extremely lossy. The representation of the data of the virtual world in Maya is very different than it is in Blender, even though largely they're describing the same things. Pixar solved this problem by creating Universal Scene Description, USD. What we looked at when we saw that, we looked at it as essentially the HTML for 3D worlds. By having a common standard and allowing all of these tools to contribute to the same common world, building one source of truth for the superset of things you might describe in that world, that opens up a huge opportunity here. We can now combine not just different disciplines within the same industry, but we can start thinking about bringing in data from completely different industries. I might have a robot that that has a description of itself in the virtual world that comes from a CAD program. You know, maybe you designed it in SolidWorks or Inventor, and you can take that description of the robot that's accurate for manufacturing and put it inside a building like the one we're looking at right now, one of BMW's factories, which was designed in Revit, and stations that were laid out there for the robots in the factory using Bentley MicroStation, and paint textures and create materials in Adobe Substance, and combine all of these things together. So that is the first part of what we really wanted to do, is establish a common way to describe these virtual worlds, so that we can use all of the existing tools out there with leveraging all of the expertise people who are experts in those tools are, to contribute to the same common world that we create. So people don't have to go relearn anything. The other side of the coin, once you have these large virtual worlds that are high fidelity, you need a way to simulate in them. You want to simulate the physics of light and matter, how light interacts with the scene, so it tells us what it looks like. That same physics, that simulation, which we call rendering, applies to wavelengths that aren't visible. So you can use that for Wi-Fi, for LiDAR, for radar, all of these things that are super important for robots and autonomous vehicles, or for Ericsson when they're laying out their 5G towers. We can use that same fundamental simulation technology that we've used for creating pretty images that entertain us. It's actually a physics simulation that's useful for a broad range of things. We need to simulate general physics. How do objects interact with each other in this world? What's the behavior? So that we can predict whether the designs that we are creating are going to be good designs. When we design a car, when we design a factory that's going to build that car, you want to make sure before you invest the billions of dollars in building the factory and building that car, that it's going to be good, it's going to work, and it's going to be safe and delightful for your customers. That simulation is key to building the things that we need to build nowadays, the complexity they're at. There's no way we're going to build all of the new bridges and skyscrapers and levees and all of the things that we need to build to buttress our environment and infrastructure without simulating them first. And in order to do that kind of simulation, we need a lot of compute, and we need a framework, a software framework that can scale to this large amounts of compute. We look at game engines as amazing, as an amazing. It's a testament to what our industry can do with world simulation. That we've developed these amazing engines that create something that's real world and lifelike that we can go play video games in. And we thought, well, what if we took this game engine world simulator thing and made it work for real world kinds of simulations, so that we can do simulations for our robots and autonomous vehicles. And what we found was that, as great as the game engines are, their primary focus is making games which don't have to be physically accurate, and they need to run on as many devices as possible, small computers, relatively small computers like phones and consoles and the like. What we need is a way to run arbitrarily complex simulations at the highest fidelity possible, and we're okay having multi-million-dollar supercomputers running those simulations, but we need a software stack, a simulation stack, a framework that can scale to those supercomputers. And that doesn't exist today. It doesn't exist with the game engines or any other simulation frameworks. So we built it, and we're continuing to build it and extend this. For our autonomous vehicle simulation, Drive Sim, we need a high fidelity world that's indistinguishable to the computer, the brain that we put inside the car, from the real world. We substitute the camera sensors, the LiDAR and radar sensors that we plug into the actual computer for the car with output from our simulator, from Drive Sim. And it has to happen in real time so we can do hardware in the loop simulation. But that rendering has to be indistinguishable to the AI from the real world, which means that we need an extremely powerful computer to run all that, many GPUs, because there are many sensors. There's a dozen cameras, LiDARs, and radars, and they're all running at real time. There's kind of like no limit to the scale at which we can do this. So we built Omniverse for that purpose. But in doing all of this, our philosophy has been, don't build anything. We're not building anything others have already done. If somebody else is already doing something well, we just want to connect it in. There's too many things to build out there for us to go build it all. We prefer to connect the existing things and augment them with the things others aren't going to build anytime soon.
So something you mentioned was Drive Sim, and I've seen that referenced a couple of times. And the first time I saw that, I went to go see if I could find Drive Sim in Omniverse, and I don't see it. Is that something that's like coming, or what's the deal there?
So in a general sense, Drive Sim and Isaac Sim aren't really different, right? Mm-hmm. They're both they're robotic simulators.
Right.
It just autonomous vehicles are a special kind of robot. Mm-hmm. In some ways, they're much harder. The simulation we need to do for them and the development is much harder than general robotics right now. And in some ways, it's easier. They're robots that really try hard to avoid touching other things. So we know that in robotics, manipulation is one the harder of the problems over between navigation and manipulation. Manipulation is the harder, more unsolved problem, right? Mm-hmm. And so that one's avoided. And it's largely a 2D thing. So your control is on the 2D plane, essentially. So that makes it a lot easier. But since we are closer to productizing that kind of robotics, and the scale is so large, and there's so much danger in unleashing AIs onto our roads that are not smart enough, it is imperative, it's critical that we do as much simulation as possible and as close to the real world as possible to ensure that our AIs are smart and they're doing the right things. So we're building that system as we speak, and it's the number one reason for why we built Omniverse, because that's a big market, it's an important market, and it's one we can't afford to be wrong at. When we don't want to put stupid cars out there. We need them to be smart.
So when I saw Drive Sim, at least what went through my head is kind of like what I was asking before, is like what I would hope for is like all these cars would either have camera sensors, LiDAR, ultrasonic sensors, stuff like that. I can't even remember. I think LiDAR is maybe not yet implemented.
Yeah,
it is.
It is.
That's okay. So like those things, and those are again very difficult to accurately model in many sims. But again, if you've got ray tracing, I would imagine that kind of goes in pretty much perfectly.
We use ray tracing for that. It's a very natural for LiDAR and radar as well. And in the keynote, Jensen talks about a bit. We've created material models for that part of the spectrum for LiDAR, and we're developing one for radar as well. Something that's not commonly done, or as far as I know. But where I'm getting to with this is that Drive Sim is the number one application for Omniverse. So all of the stuff we're developing for Drive Sim that can be generalized goes into Omniverse. And Omniverse is a toolkit you can use to build simulators like IsaacSim. Anyone can actually take Omniverse and build their own special simulator and system on top of it. It's a platform, a development platform for that. Eventually, I think we may put DriveSim out there or license it out. I don't think we've decided on that. But for right now, it's still like really on the bleeding edge of development, and it requires very specialized big iron gear to run the way we're running it. You need to simulate all of those sensors in real time simultaneously with hardware in the loop. You're talking about a computer with dozens of GPUs and specialized interconnects. It's a supercomputer, so it's not for everyone. It's not like, even if you downloaded DriveSim today, you're not going to be able to run that on your laptop.
So what would be the heavy part then? So like, is it just simply, is it the number of sensors, or do you have, I guess in DriveSim you'd have like pedestrians and cars and all kinds of other things going on, or?
Yeah, first and foremost, the worlds are large. I mean, it's arbitrarily large.
Right.
If we want to get to the point where we can drive across a continent from Los Angeles to New York uninterrupted, and like I said, what we're really going for here is essentially virtual reality for the AI. So we take the computer that would actually be in the car that has connectors for the sensor inputs, and we replace those sensor inputs with outputs from the simulator, like video out from the simulator, plugging right into it. So it has to run in real time, but worlds that are continent scale, and each pixel has to be faithful to what the actual camera would see.
Right.
That is essentially an endless problem. Like to do that the fidelity rendering we want, for VFX and film, like stuff that's indistinguishable from the real world, they spent computer days worth of rendering time on the computer per frame. And we need to do that in a 60th of a second. And we need to do it for dozens of sensors. So one GPU is nowhere near enough to do all of those sensors at that fidelity. We need a much bigger computer to do that. And so we're building Omniverse as a simulation framework that lets us scale to that. So you can put these large scale worlds in there and crank up the fidelity and accuracy just by throwing more compute power at it. Eventually, our computers get more powerful, our GPUs get more powerful, so you can run them on smaller and smaller computers for a given data set size, and it'll make more sense to give others access to that. But all of the stuff we're doing for sensor simulation, for the world creation, and all of the features that are in there are just in Omniverse, and they're in IsaacSim. So you could potentially make something like DriveSim on top of IsaacSim. Say you wanted to make a delivery robot to simulate delivery of food from restaurants, like do a DoorDash kind of thing. That's essentially a DriveSim problem. So we'll see. Over time, we'll be releasing more and more of the things we're building for DriveSim. It's just not ready yet right now for general consumption. I think most people couldn't use it in its current form.
Well, at least from my perspective, what I would want from DriveSim, and maybe it doesn't even need to be called DriveSim, is the same thing I asked about earlier, is like, I just want an asset I just want the car and maybe like some roads or something like that. It doesn't have to be an entire continent. I just want
and
the
that's
asset
coming.
with
So as far as the asset
and all that.
Right. As far as the world building part, there are, besides us, there are a lot of companies out there that are building these assets and making them available. Companies like TurboSquid, Shutterstock TurboSquid, and so you should look at that, see what's already out there.
But surely the problem there is it would not have the like the hard part in my head. The thing that I'm trying to skip doing is adding in each individual sensor, because I think that's still, I don't think I could just grab something from TurboSquid and let's say the front facing camera. That's not gonna work. I've got to still go into Isaac Sim and like add those things in. Correct.
Yes, you're going to have to place the sensors relative to the car, but I don't think that's that hard right now to do. We've added tooling to make that easier. Over time, we would like for these libraries like Turbo Squid to have richer assets for our simulations that already come pre-configured with all of that stuff, and that is definitely something we are pursuing. I can't talk about specifics, but our dream is for Omniverse to open up new markets for all of these content providers, so that they're incentivized to create richer assets that have more than just the geometry and textures, but also have all of the physics materials. They have the rigs, so the cars are rigged up. You can just drive them. For indoor scenarios, it's really important to have to have your assets be rigged for things like drawers and refrigerators and cabinets, all of the physics and the joints and stuff. Generally speaking, none of the content out there has any of that stuff. It's really basic, but we're trying to standardize the description of all that stuff to make a market for them to go produce that.
And that's USD essentially, is what you're saying.
Yeah. So we start with what USD is today, which describes a lot of it, but not all of it. There's physics and behavior, and these things aren't standardized in there. You can add it. You can add that information, but there isn't a common way to describe it. But we started working with others to evolve it in the same way that HTML evolved greatly from its inception, from HTML1 in 1993 to HTML5 in 2010 or whenever that was. There was a lot of stuff added. In the early days, you couldn't do things like video or have a rich application with asynchronous UI events like Gmail or Google Maps. But all of those things were added to HTML to give us the experience that we have today. We believe the same is going to happen with USD, and we're accelerating that. So last year we worked with both Pixar and Apple to add one of the first schemas to the USD standard to describe rigid body physics, and that has become part of the standard now. And we're working on more such things, and we think it's going to be a journey. This is something that's going to just continue going the same way it has for HTML, and HTML hasn't ended. It definitely is going to continue for 3D data, and we believe that's USD. And describing 3D worlds is much more complex than describing a 2D web page. So by necessity, we need to we need to create these new standards.
We
do it together.
Got a comment in the chat that I think is kind of interesting, and I know it's not available now, but the concept I think is really interesting. You've got stuff like audio to face, which is an application now in Omniverse, and obviously that started with just like a neural network that would produce that for us. And Zartris in the chat suggested that is there a possibility in the future that someone can, because I've seen people do this where you take a photo and then that photo is converted to like a 3D space. Mm-hmm. And we call that Canvas 3D. That would be so cool to have in something like, because that would be, because then you could like set up, obviously you'd have to make some slight tweaks and stuff like that to the physics once it's loaded in, because obviously a photo doesn't contain physics, but it could, it could be inferred from the photo. So, is there any?
Well, we did that, and that's actually available in Omniverse right now.
To take a photo?
Technology Canvas 3D. It's an extension that's available. You can enable it if you go to the extension manager and create. You can enable it, and you can give it a photo of any car, and it will almost instantly create a 3D car for you with texture and rigged, so you can drive it around.
Is it only for a car, or can it be? Is there a
that one is only for a car? The technique is generalizable to everything, but the one we put out there just as an experimental thing for people to play with is only for cars. That was developed by within the Omniverse team. We have a basic research lab in AI that's dedicated to 3D content creation. It's led by Professor Sonia Fidler from University of Toronto, where modern deep learning and AI was kind of born. She's amazing, and she's assembled this amazing team that is bridging AI and computer graphics and simulation. So that particular technology was published. That's from her group. Our team there, which is part of the Omniverse team, and it's just a little taste of the things that are to come. I mentioned earlier that today building high fidelity, large 3D worlds is really hard. There's only a small number of experts that can do that, and we believe that in order for us to build what we need, all of the virtual worlds that everybody needs to use to build everything else, we need to make that skill or those skills available to everyone. And the way we're going to do that is with AI. AI has to assist in this construction. And so this lab that we have is for that purpose. We know that there's no way we're going to scale. It doesn't matter how great our simulators are, how perfect they are. If you can't give the simulators the data, the worlds to simulate, you can't make enough of them, then it kind of doesn't matter. So we see Omniverse as solving both problems, the simulation and the world creation problem. They're two sides of the same coin.
Just again from my own personal notes. So this was an extension in the Create app in Omniverse, and what was the extension called?
I believe it's called Ganverse, GAN. Like
Ganverse. Okay.
Generative adversarial networks. So Ganverse 3D.
Very cool. I'm gonna definitely have to tinker with that.
There's some videos out there. So we have a whole bunch of little tutorial videos and stuff on Omniverse. I think if you just search for it, Google or YouTube it, search for Omniverse Ganverse 3D, it'll come up and it'll show you how to use it.
Cool. Yeah. Shout out to the Omniverse team. I what is it called on Twitch? I think I followed them on Twitch, and then they're always putting out content. So if you're interested in this stuff, definitely they've got a bunch of YouTube stuff and then Twitch stuff too that you can come in and even talk to them live. So if you're interested,
and we have a cool Discord where much of the Omniverse team frequents. So if you ask questions there or come chat, there's others in the community that are really starting to gain expertise in it and can help others out. It's discord.gg/NVIDIA Omniverse, one word.
So one of the other things too that I think is pretty newly announced as of today is the AR and VR side. Can you tell us a little bit more about that? I saw the AR is like in beta, and then VR is coming. I think that's right. Yeah,
it's also coming in beta. These are fundamental capabilities to Omniverse Kit that we're making available. We've shown them in different forms and stuff throughout the years as we've shown Omniverse, but we feel they're far enough along now that we're going to make it available to the general public to build on top of. So with AR, you can download a companion app for your iOS device called Omniverse Remote that allows you to connect to the computer that has the RTX card running Omniverse and have the rendering of the virtual part of your AR scene done by the bigger computer with generating the better pixels, streaming it to the iOS device, which can then composite the rendered image into the real world camera feed. So you get that AR feeling, but without the limitations of the rendering capabilities of the device.
And is that like pretty quick at inference and stuff? Like, are you guys finding that with a typical RTX GPU that people are able to do that, or like what kind of GPU?
As long as the content that you're rendering, as long as the GPU that you're using is capable of rendering that content at real-time frame rates, then yes, it's great. there's no limit to the complexity of content you
Right,
can
right.
create. Obviously, you can always create a bigger world that has more complexity in there. So at some point it stops being real time, and that all just depends on the computer. So, but if you have any of our modern GPUs with RTX, then there's a lot of cool stuff you can do, and it's definitely far more capable at rendering and rendering high quality than what a 5 watt iPad can do, or an iOS. As amazing as those devices are, you're limited by the capabilities of the thing that's driven by a battery. If you can plug a computer into a wall, you can do a lot more computation. And so this is a way of having the best of both worlds. You can be untethered, have your AR experience on the device you want to display on, but the computation is happening on a bigger computer that's connected to it, and potentially even in the cloud. You can run it. It doesn't even have to be in the same room with you. You can run it on AWS or Google Cloud.
So just to stop for a second, I think what's on right now is what I referenced earlier. So this is Maxine. So my question would be, again, getting back to my dream, can I, is that the only avatar essentially that we can use, or can we transfer learn our own face into that?
Can you create put your own face into this avatar? Yes, that's exactly, I think, what we were showing here. We have a whole host of technologies for creating these avatars, ranging from photorealistic, coming from the real world, to imaginary, artistic ones. But yes, one of the options is to use your own image and drive yourself. But that image could be with you wearing different clothes, makeup, or dressed a certain way, so you can be untidy and unkempt and
Perfect.
in real life, but seem as if you're all dressed up.
Well, that's one of the other things that we've seen, at least over the last, for sure, year, but probably longer. It's all kind of a blur now. But just like the technology to, like, even right now as we're talking, like for me to look at you, I'm looking at my screen, but I've got a webcam over here. And wouldn't it be nice if I was always able to like look at the webcam? But for me personally, that's awkward, and I feel like I'm losing out on the personal interaction
Absolutely.
if I'm not looking at you. But then it's weird for you because you're looking at someone who's not looking at you. And so even like little subtle things like that, and the fact that, again, we can just do that in real time. I
Yeah,
find that
it
super
turns out a
cool.
huge part of our brains are dedicated to that, to deciphering and decoding what other people mean or intend based on their gaze, based on their facial expressions, based on where they position themselves in the room relative to you, their body language looks like. We're really, really attuned to this stuff. We communicate a lot of information without saying a word. And often the words that we say are conveying less information or the wrong information than what the rest of our body is saying. So we're really good at that. And with video conferencing, the reason why it's so tiring for all of us is because it kind of breaks all of this. Right now, it looks like you're not paying attention to me because you're looking away from my face, but you're probably actually looking at me. Your intention is to signal to me that you are engaged and paying attention to what I'm saying. But the way my mind is reading it is that you're disinterested because you're looking away.
Right.
And I have this cognitive dissonance because I know consciously that you are paying attention, but there's a signal in my brain saying, no, he's not. And that fights. Those two things are fighting each other, and it tires us out. That's why we're all sick of doing this video conferencing stuff and want to meet in person.
Well,
But
I think
with
it's
these
also,
technologies, we can remedy a lot of that even today.
I think it's also two-sided though. Like I said, like I think not only do you feel like I'm not listening to you, but if I attempt to listen to you, I'm staring at a very boring, unhuman camera.
Right.
And it's
Yeah, it's
immersion breaking
because
for
the
me.
camera isn't aligned with my eyes.
Right.
which is you're looking at my face and probably at my eyes, but the camera is offset from that, so it looks like you're looking away from my eyes. We can tell when somebody at a far distance is actually making eye contact with you.
Yeah.
It's really like, even though theoretically the resolution of our eyes shouldn't allow that, you can see them from way across the distance in our room. We know, because that means something. It's meaningful when somebody is trying to connect with you and look at your eyes and communicate something to you. But this completely breaks it. So we Jensen talks about this in the keynote here. We've talked about it in the previous one as well, about gaze redirection as one of the cool technologies we have as part of the Maxine toolkit that could be rigged up into video conferencing or similar kinds of applications.
Interesting. Yeah, I'm definitely gonna have to check out Maxine again, because again, that gets very close to what I'm after. So in the frame that I've paused on here, they're also showing that you can convert text to speech into another language. So is Riva connected into Maxine? Like what's the structure of this?
Yes, Maxine leverages many of our foundational technologies, including Riva. That's how I would look at it. Like, Riva is kind of a lower level component that could be used with Maxine.
Interesting. Okay. Yeah, I'm definitely gonna have to look into Maxine some more. So the other thing that we kind of glossed over was, we talked about AR, but then I still want to hit on VR, because again, like that's just so interesting to me, to be able to possibly create, my own environments. And again, yeah, like I think I'm a pretty good test case, because I don't really, like, I think I've used Blender maybe once in my lifetime. I don't use Photoshop. I'm not good at any of these things. But again, like with Omniverse, I'm able to kind of create what I need to create pretty quick. And then so the concept of possibly being able to continue using Omniverse to create something in VR, and then be able to pass through robots that I've also created and have those in VR interacting with me in VR, like that's really staggering. So like what's the roadmap there? Do I have a good idea for, like, is that going to be possible for me to do?
I don't know if you remember, years ago we had a project that we had shown in many of Jensen's keynotes called Project Holodeck.
Maybe, but I've definitely...
You can search it up, NVIDIA Holodeck. We took a bunch of our rendering technologies and physics technologies. Actually, even before that, we had another project. We made a mini game, a physics game in VR. I think it was 2016. Yeah, 2016, called VR Funhouse. We took Unreal Engine and we added to it a bunch of technologies for rendering in VR and some cool rendering stuff, plus physics, and made a VR experience where you can interact with the world using a lot of physics stuff, which is super fun. We had fire and destruction and we had furry bobblehead things on springs and stuff. You should check it out. But we extended that. We thought that was an experiment we had done to see, because it was in the early days of VR. We had an intuition that in VR, accurate physics would probably be really engaging. Like, for you to feel immersed inside a world, you need things to behave correctly. And VR Funhouse proved to us that that's true, that it is. It was pretty awesome. So we then took it and said, well, let's make it multiplayer, so many people can be in the same world together and do things with physics. And we thought, well, how about, instead of it being a game, designers could use this so that they could go look at the things that they're building, like cars and products, but interact with them physically with multiple people that could be different parts of the world, feeling like they're in the same place. So we started Project Holodeck, and we built this cool thing on top of Unreal Engine. But soon after we built that, we realized we had the runtime part, like we could do all the interaction, but the real problem was getting all of the content into these worlds to build them and importing from everywhere else. And that really brought it home that we needed to build what is now Omniverse first before we can tackle that problem. Like the actual world construction problem is the major part of that. So we took a break on Project Holodeck and went off to go build Omniverse. But the intention has always been that we'll get back to using all of this stuff for VR, AR, and all of the new modes of immersive experiences. We've had VR technically working in Omniverse for a long time, but it's not enough to just make the stuff render in stereo and experience in there. You need a whole UX, a user experience, so you can navigate around the VR world, so you can manipulate objects in there. We need a toolkit that lets you create UIs inside the VR world and all of that. And so that wasn't the highest priority at the earlier parts of Omniverse. We just needed to get everything working. We need to get rendering and physics and the basics up and running. But now that we're a little bit further along, we're enabling these things that have been the plan all along. Our goal is to get to the point where people have a choice on how they're going to interact with these 3D worlds and content. If you want to experience it with mouse and keyboard, looking at it through your monitor as a window into it, that's fine. If you want to see it, you want to mix it with your other reality, with our reality using AR glasses or an iPad or something like that, and place that virtual world on a tabletop and experience it that way, go right ahead. If you want to be inside the virtual world and feel like you're in there, immersed in it, then VR is the way to do that. And with Omniverse Nucleus, we can connect many people into the same world, and all of them can have different views into it in different modes. So it's not either or. One person can be inside in VR, and another could be viewing that person in the virtual world on a tabletop through their iPad, while a third person is connected to it with Blender or Maya and modeling and changing the world on the fly like they're God inside this virtual world. We have all the foundational technologies to enable that today. And what you're seeing here is us opening up some of the technology that's been in there for a while, because it's becoming robust enough and polished enough so that we feel okay unleashing it onto the developer community so they can develop new experiences.
What I want is commitment. I want an ETA. When can I play with that?
The VR very very soon. Like it's working, so it's good. I don't want to. The way I feel is that there's nobody on the Omniverse team that is sitting around idle and lazy. They're all working really hard, and so this is a priority for them. They're going to release it as soon as it's ready, because they want it in your hands. But if I force them to release it earlier than they think it's ready, then you're going to have a bad experience. But so I don't like to put a specific date, but it's on the order of weeks at the most.
Cool.
We announced it. It's out there. I think actually you can enable VR right now. There's a whole bunch of stuff. There's like hidden not even Easter eggs. They're just in the extension manager and in the render settings and stuff. I think you can, if you go to the render settings, you can enable a VR mode. Stuff that's coming is a lot of the things I mentioned, like navigation and locomotion inside the VR world and manipulation and all the UX kind of features.
So is that like VR? Is that in Create, or is that also in like things like Isaac Sim and stuff like that?
So it's in Kit, which is the framework all of these applications are built on. So theoretically, it's in all of them.
But I want to go to like, I I don't know, some file menu and say, send to X display, and that display happens to be some VR headset. Is that kind of what's coming, or like what would be like the pipeline? Like, I've got my environment, I've got my robot in there, and I want to interact physically with my robot. What is your hope for how I would do that?
There's two ways I would imagine you can do it at home. You can either, the same machine you're running Isaac Sim on, you can just flip it into VR mode, and your VR HMD is connected to that computer. So on the screen, you'll see the two views, the stereo views, and you just put on the HMD and go do your thing in there. And when you're done, you take it off and you get out of VR mode and it goes back into desktop mode. The other way you can do it is by hosting that virtual world on a nucleus server, local inside your network. So it might be the same workstation. Mm-hmm. And if you have another machine that you're using for VR that's different from this one, that you can load that same scene up from Nucleus on that other machine in even another app like Create, while Isaac Sim is running on the same USD data in the same virtual world. And you can put on that headset and use that separate computer for VR, while the first computer can be used for editing or running the simulation in Isaac Sim. The problem you have in running it all on one computer is that you become limited to the total compute capabilities of that one machine. VR is not cheap. It's You need high resolution and you need stereo. So you need a fairly powerful computer and a lot of GPU horsepower, which doesn't leave much budget for you to run your physics simulations or other things you might want. So it all kind of depends on the scale of the simulation and the way you're trying to use it. We're giving you the capabilities and the flexibility to do this whatever way works best, given your configuration.
One thing, but after this. But speaking of high-powered GPUs, I just want to mention that if you sign up for GTC, there is a link in the description. It is free to sign up. There's lots of really, really interesting talks, including on like Omniverse, stuff like that. You have a chance to win one of two 3090s. So sign up if you haven't. It's definitely one of the best GPUs you could possibly have for stuff like this. So
it's what I'm using. I love my 3090.
Yeah, you mentioned so you could have like a computer on network. Is there a reason why we couldn't just have like a public IP and then do it that way too, or is this like a security risk? Like what?
Absolutely, yeah. So if you're going to put a public IP, put it out there, then you need to ensure it's secured. So you VPN or encrypt it somehow. Over time, we hope to make that easier to do. So ideally, at some point in the future, you don't even have to buy a computer to use Omniverse. Right. You can just rent them as you need. We obviously do that already for video games. We have GeForce Now, so you don't have to buy a PC to play these games with full RTX quality at 3080 level. You can just subscribe to one there, and I can't give any specifics or dates, but obviously that's the future, right?
Well, obviously, in theory, you could spin up like an AWS server or something like that,
and you could do it yourself,
yes, and then connect to it that way.
It's just like you're renting a PC in the cloud, and you can do whatever you want with it. And there are PCs in the cloud that are Omniverse compatible or capable. So,
yeah, that's crazy. All I know is like I can't see past that horizon, of like what happens then. I just know that's just so cool, like the concept of it. And it's kind of like with like Transformers today, we're just kind of starting to see some cool stuff. Like I've been playing with the Copilot, and I think these are things that are just going to completely just paradigm shift the way that we view so many things. I don't know if it'll always be Copilot. It'll be probably many iterations later. And then same thing here.
I agree with you. I think there's going to be all kinds of emergent things amazing things that happen that we couldn't quite predict. I've always found it odd that for essentially all applications that aren't 3D, they've all moved into the cloud primarily. But 3D applications are primarily run at the edge on your device. And you would think it would be the inverse, because like 3D world simulation and the data sets associated with 3D are so big that it makes more sense for that to be concentrated in the cloud with data gravity. Now, the reason why that hasn't happened is because 3D is just super, super hard. And you have this fragmented ecosystem of all these different tools that all speak different languages and all of that. So we wanted to build Omniverse to allow that. If we can describe the world in a common way and make a framework so that many different compute entities can connect into that same world and operate on it, then we essentially cloud enable it. If you think about the applications you run today, one of the most common ones is like a Google search. That is an application that's impossible for you to run at the edge. You could not do a Google search completely on your phone or on your PC. That requires access to enormous amounts of data that can only fit in a large data center somewhere. And every time you type in a few words into to the text entry box and press enter, get that instantaneous response, you've touched terabytes and terabytes of data. Probably dozens or hundreds of computers did something with all these little microservices and stuff operating there. But to you, it looks like it's just one application running in your web browser. Right. Very simple. 3D, if we do this right, will become like that, where the stuff that we do inside these 3D worlds has an enormous amount of like unimaginable amount of computing with algorithmic innovations and stuff happening, but all instantaneous behind the scenes without you even knowing. And we're going to do things that are only possible because it's in the cloud. You would not be able to do that computation in that period of time or at all on the device you're actually experiencing it on. So this is the first steps towards doing that. We need to construct the plumbing. We need to describe the standard ways of describing the data. And then we need the plumbing to connect all of these systems together with microservices, databases, and all of that stuff. So we can enable these new kinds of applications that are just right now unimaginable. We don't know what they're going to be like. In the same way, we couldn't have imagined all of the web applications we have and all the apps that we have back in 1993 when the web first arrived.
Well, I think, it's not even just can't imagine too. It's like, when I was first poking into GPT-J, which you can theoretically run locally pretty quickly. And even that is accessing a theoretical like knowledge base of, I can't remember how big it is now, but a very large corpus of just knowledge. And I think a lot of people are, they see that and they're like, well, what do we do with this? And it's like, well, it's not a general intelligence, but it's generally intelligent. And even though today maybe most people can't run something like GPT-J or any of these other, let's say 5 to 10 billion parameter models, maybe not yet on your phone, but in a few years you will be able to, or you could run it on some sort of Raspberry Pi sized device. But
then there's going to be a model that's thousands of times bigger than that can only run in the cloud.
Right. So there's going to be all these new changes that, exactly. You'll have much, much larger models that are, again, going to be generally intelligent. And it's just trying to like start it again. It's like I see that. That's the horizon. I don't know what's beyond that, but I do know these are technologies and capabilities that we've really never had before. Like you mentioned, like Google search, that's kind of the first one that I can think of that is like gives someone immediate access to the world of knowledge. But something, beyond that with these very, very large transformer models, it's not just Google, like because most people can't just connect into Google Search API. I mean, they do have like an API, but it's very, you get rate limited very quickly. So you could not have a robot with this sort of general intelligence unless you were, Amazon or Google or one of these other very large tech companies. Whereas nowadays, no, you can download that model and you can run it right now.
Or you can get it from us.
Right, that's what I mean. Is like now you can getting back to like Riva and stuff like that. Is you can grab these models and they're already optimized. Like that was, I think for me personally, the biggest surprise was the captioning or the transcription rather, where just how fast it worked. And then from there, at least what I did was I used the ASR and then fed that through, was it Dialo GPT I grabbed that model from Hugging Face. I did not train that model. And so I passed it through that model, get the inference response, basically a chatbot response. And then I used text-to-speech again from Riva to respond to me. And again, that whole process, I fed that through the microphone and then it talked back to me over the speakers. And it was very, very fluid. And I think that whole project took me, I don't know, 40 minutes maybe to complete and like do on a tutorial. Whereas, to do all of those steps myself would have taken, I don't even know how long. And I don't think I could have gotten the inference to be that quick, even though, again, that was all running on my own hardware. So it wasn't
we have a large team of people whose only job it is to make that inference quick. And they're the world's experts on computer science and computer architectures. Like there's just no way you could do that. I know I can't. I can't do that. We have the world's best people for those specific things doing that, and we can justify dedicating them to this because it's going to be used by many more than just us. We do this because you can go leverage it, and so can thousands or maybe millions of others. That's fundamentally our position in this. We are tools makers. We create core technology that others can use as building blocks to build their applications. We're not looking to go make the end applications, the final solutions.
Even though, I mean, you guys are very close to doing just that. I mean, it's like, they're just like these end piece software bits that someone like me can just kind of just plug in real quick, and it's like boom, I have a very nice chatbot that is like something that I could not have created, and I would not.
And you can go specialize that to your problem,
right?
For what you need. We're not going to be there's a lot of people at NVIDIA, but by the grand scheme of things, it's not that many. We're about 20,000 people in this company. It's actually much smaller than if you look at other equivalently sized companies there. There's only so many things we can do, but there's only so many hours in the day that our engineers can type. We can't go make every application that every person needs in the world. So we go focus on the core common things that are super hard to do that we're particularly good at doing, that we can add value with, and then we provide that to others so that they can go specialize that and apply it to their problem domain. And that's what Omniverse is as well. You had asked earlier about, you see that there's overlap with some existing tools. That's not at all what we're trying to do. We want to use all those existing tools, but augment them with unique capabilities that only we can really provide, given our special capabilities and our experience and our passion.
So I just happened to catch someone in chat suggesting, asking about like basically gaming GPUs versus doing stuff like deep learning. What do you think the focus is of NVIDIA primarily? Is it gaming, or is it what would you call it? GPU use, I suppose, like GPU accelerated. Is it just everything GPU accelerated, or like kind of what's the thinking?
So how to answer that exactly? We haven't been only a gaming company or only anything company for a long, long time. We started with gaming from the very beginning because we knew that in order to build the, are you getting an echo, by the way?
No, I'm
getting
okay. Possibly if someone says in chat, but multiple people would have to say in chat. People lie.
I see. Okay, I'm getting an echo, but I don't know, but I'm not sure where that's coming from. I'll try to speak, ignoring my own voice. So we started our history, our life at NVIDIA in 1993, to building a accelerator for rendering, so we could do real-time rendering. And the first market Jensen identified for it was one that didn't exist yet, but he believed was going to be important. It's video games, 3D video games. We love video games. All of us are gamers around here. I'm a gamer myself. But the reason we chose that one was because we understood that it was going to be big enough to fuel the R&D we need to do to build the accelerated computing stack that we want to build to expand into other things. Because the fundamental technology and algorithms and innovations that we create for video games are useful for a much broader set of things. To this day, video games is a huge part. It's still about half of our revenue, but increasingly it's becoming a smaller share because we've expanded into general compute, high performance computing, pro visualization, and most recently, for almost 10 years now, deep learning, and all of that is growing into the data center. So our businesses and where our revenue comes from, share-wise, it's starting to shift. Gaming will always be a big part of it, but we're doing other things, autonomous vehicles, robotics, and all that. But fundamentally, what we're doing is the same. We're building a computing stack to accelerate computing for simulation for really hard problems, for not all problems. We're not, we haven't been like general computing companies, general chip companies that only build CPUs where you can run any program. We've gone and focused in areas where speed and large amounts of data and compute really, really matter. And we've created full computing stacks that include not just our chips, but the system software, compilers, libraries and SDKs, solutions, and even applications to accelerate that and make meaningful differences there. Gaming was the first one of those, and we'll continue doing that, but we're expanding into everything else, and I think you're seeing that every day with all of the things we show out there, and definitely in this keynote. Also, it's no secret that we make more than GPUs. GPU is the primary thing that we do and what we excel at, and nobody, as far as I'm concerned, comes close to making a GPU as great as ours. But we also have made CPUs. They've been in our Tegra devices and our Edge device forever, ARM-based CPUs. And earlier this year at last GTC, we announced Grace, which is our big data center supercomputing class CPU that's coming later, built on ARM. And we also have a DPU, our data center processing unit, which is an extension of all of the technology we acquired when we acquired Mellanox. We're looking at data centers as the new unit of computing. When we think of a computer, it's no longer just this PC that's sitting next to your desk or your phone or a console. The whole data center we think of as one computer. And that means all of the processors and the networking, interconnects, all of that is part of one architecture. So we build all of those things.
Yeah, I don't know how much you can speak to this. I haven't kept fully up to date on it. What is the status, if you can say, on the NVIDIA and AMD merger, I guess?
NVIDIA AMD merger?
Or I'm sorry,
ARM.
not AMD. I'm sorry, ARM. Yeah.
So
ARM.
I honestly, I don't know any more than you do. Whatever's out in the public out there, we we would like to acquire ARM. They would like to be acquired by us, and we put that out there, and the regulators and all of the different countries have to weigh in. These things take time, and we hope it happens. If it doesn't happen, it's not the end of the world either. We're building ARM-based CPUs as we speak, and we'll continue to do so. We think ARM is really great, but if the merger, the acquisition does go through, I think it's going to be a real boost to the ARM ecosystem. We can put the full might and energy and power of NVIDIA's R&D into ARM CPUs, and scale them up and put them in places they've never been.
So I got another question too. We'll probably wrap this up at some point. I don't know how much more time you have, but we're a little over 2 hours now. But since we're talking about CPUs and other compute devices, the other thing that was brought up in the keynote, and I've heard it before too, is I think it's Quantum. And obviously this is for quantum simulations run on the GPU. So that got me curious. Whenever that first was released, the thing I'm waiting for is CUDA with a Q. And that's hopefully on some sort of quantum device that, NVIDIA has developed. So I'm actually in the process of trademarking that. That's my exit strategy for YouTube. So do you guys have like a future plan, or obviously maybe not even something set in stone, but is quantum something NVIDIA is looking into to possibly?
We're heavily investing in it. We're helping so it's no secret that it's probably going to be a little while till we have quantum computing be a common thing that everyone's doing. We're not there yet, but to get there, we need a lot of tools and traditional computers to help us build those quantum computers, to do the simulations, to do the basic science and research for that. And so that's how we're playing that right now. That's our contribution. We're investing heavily in that. And Jensen, in his keynote, goes into quite a bit of depth on what our efforts there are. I encourage everyone to take a look at that. Once you have a quantum computer, you're not done. You need to verify that it's correct.
Are you aware if Quantum throws in like that noise and stuff like that? Yeah, that was like one of the other interesting things that you can't, like the quantum computer might process quicker, but generally you have to like you have to like process it multiple times just to make sure there was like no noise, right?
Right.
Does the simulator simulate that, like the noise, or is it a perfect simulator?
I believe so. I'm not an expert on quantum computing, but yes, my understanding is that even once you have a quantum computer, you still need a whole bunch of traditional compute around it.
Yeah.
To make it work, and so we are investing heavily in building all of that infrastructure to enable quantum computing.
And then I think probably the last thing in my notes that I really wanted to bring up was Coonumeric as well. So I guess that is probably powering Rapids. I remember looking into Rapids some time ago, but I haven't really kept up to date with that. So I think in the keynote, Jensen also said that there's like a NumPy version that runs on Coonumeric. Do you know
I think
further?
You change one line, basically. I think you change import NumPy to this, and it automatically accelerates your NumPy code, which is pretty amazing.
Yeah, I'm super excited to kind of peek into that, and then especially for so last year, Daniel Kukewa and myself wrote a book called Neural Networks from Scratch, and we end up using NumPy. And the idea would be to get that on the GPU. So when I see that,
your own stochastic gradient descent and all that, just right in NumPy.
Yep. Yeah. And so, but obviously this is all running on the CPU. The idea of this isn't to create our own framework. It's just to like teach people how to, like how this actually works. And
computer graphics, generally the equivalent of that is writing your own basic sphere ray tracer.
Yeah, exactly. And so, I for sure, I at least can personally attest as we went through that, like I learned so much, and it's helped me a lot. But anyway, like getting that onto the GPU, because going from here it'd be cool, because that's just
I'd love
with
to find out how it works for you. That would be
that's
awesome. Just
that's just
take your
like
code and
yeah, exactly. And like that's just a dense neural network, but we would like to go to do things like reinforcement learning and transformers, stuff like that. And especially when you get to reinforcement learn, so at least some of the reinforcement learning algorithms, and then for sure transformer models, we would like to have it at that raw NumPy level, but also the speed of CUDA on the GPU would be nice for like training the models and validating that they work. So just seeing that got me excited, because
we love the idea of bringing GPU acceleration, the full power of our GPUs, to the bigger world of Python programmers.
Mm-hmm.
The number of people that can code at CUDA at the level, at the systems level,
yeah,
and do it is it's just really hard. And even if you know how to do that, you don't necessarily want to. It's just a lot of work. It's hard. So me personally, I like to be able to describe my algorithms at a high level in Python, and just have it be fast. Maybe it won't be the maximum possible acceleration, but even if it gets me less than that, if I get a 10x speed up without having to do anything, and I could just code up this thing and experiment really quickly, that's extremely valuable, because I wouldn't have, in many cases, gone through the trouble of doing the most optimized code to do some experiment in CUDA or C++.
right.
So I think that's great. And within Omniverse, we had a huge debate on what we should settle on as the primary scripting or primary language beginning. And of course, as you can imagine, everybody has their favorite language.
Yeah.
And there's always somebody who wants to create a brand new one. And finally, we just converged towards Python, because like that's becoming the lingua franca for all things. It turns out that Python was adopted early on in computer graphics, in visual effects, so that's already common there. The USD library had Python bindings, and that's like the most natural way to use it to begin with. And then data science and machine learning and AI, that's all Python. So we're everything inside Omniverse is essentially Python, but you can drop down to C++ CUDA if you need. And we're even introducing ways of programming the GPU directly through Python, make it easy for people who are domain experts in their physics or the types of simulation they want to do, to describe algorithms easily, but get as much of the power of the computer they're running on as possible, and keep that code maintainable as well.
Yeah.
And portable.
Yeah, that's so cool. These keynotes, and just the amount of stuff that is like coming out. I mean, it's not just from NVIDIA, but it's like I can barely keep up with what NVIDIA is doing. It's like there's just so much just advancements. Just like you said, by the time you're done training a model, it's like it's not even the industry standard anymore. It's changed.
Yep.
It's just it's so crazy how quick things are changing.
It's very exciting.
Yeah, I think that's pretty much everything that I wanted to cover. If there's something you think I've missed in,
I think we went into quite a bit here.
Yeah.
This was really great. It's the first time I've done this, and
yeah.
I really enjoyed it. Thank you so much for giving me the opportunity to speak with you and to your audience.
Yeah, sure. Well, thanks for coming on. I pretty much never live stream, so it's and definitely not with somebody else and stuff. So I really appreciate your time too. It's good to have somebody who's just so deeply embedded with NVIDIA that we can ask these questions basically to the source. So that was definitely super helpful.
It's my pleasure. Look forward to doing this again sometime.
All right. Well, thanks again.
Take care.
All right. Bye-bye.
Bye-bye.
All right, guys, I'll probably hang out in the chat for possibly a little longer if there's any other questions or anything like that. Otherwise, I'm going to go and eat breakfast, I think. Oh, I say we have Edmar. Edmar's also with Omniverse. Where are the free GPUs? Ramming the GPUs, so you can, there's a link in the description. You can click that, make sure you sign up for GTC, and then I was searching for the description here. But anyway, in the live stream, you can click on that link and sign up, and there's basically, out of the however many people sign up, there's 2 GPUs that will be given away. What's for breakfast? I don't know. Probably some eggs, turkey bacon, and cheese. That's typically my go-to. Zenny, yeah, the deep learning book is finished. You can get it at nnfs.io. Zebo, yeah, I probably will, especially I think if I can figure out how to use it. You know, a lot of these new things can be kind of difficult to just like ramp up very quickly on. So like Coonumeric, my use case there would be to attempt to apply that to the NNFS package. So getting that to run on the GPU would be just really, really cool. So if I can figure that out, yeah, I definitely would do some videos on Coonumeric. Krishna, yeah, there is a Discord. It's quite literally discord.gg/Sentdex. Mental, my primary operating system is Ubuntu, but I also sometimes go into Windows. I used to be on Windows completely, but maybe like 2-ish years ago, I switched to Ubuntu. Shall we have more streams? Possibly. I think, at least for me, doing streams, I don't know. I liked this one, having someone else on the stream. I think if I do more streams, I would probably want somebody else like in the stream. So, like I liked this format. Generally, it's very boring to me because usually like if I'm coding or doing something, I'm like listening to music, or if I'm doing like a tutorial, it's like maybe 15 minutes, whereas streams tend to be hours long, and it's very like, I don't know, it's weird. It's weird feeling to me, at least. And like music on streams is always a danger. Did they release Coonumeric? As far as I can tell, like that's out and ready to be used right now. I think Coonumeric is what powers Rapids. I'd have to. You only see alpha? Yeah, I mean, can you? I don't know if you can download the alpha or not, but I assume it would be out. I don't know where I'm seeing worldwide Sanjay's responding to somebody, but if that's about the GPU, yeah, you can. Everyone is eligible for that GPU. I've asked, so they pay for shipping, and like the taxes, all that stuff will be paid for. So I think that's all the questions. So I think I'm going to sign off of this stream. Thanks to everybody for watching. Again, the link is in the description if you want to sign up to GTC and be entered. I don't know what the numbers are now, but it was like in the hundreds. It's like 2 out of something hundred for a chance to win the GPU. So it's pretty good odds, and it's completely free to sign up. And there's just endless awesome talks. So definitely check those out. Thanks for watching, everybody.